Yes, did it say no? So no, it didn't say I'm not saying I'm not I'm human, so I thought that was fun. No, and she's too full like things are fantastic. No. That's how I did it. I love it. So I would even help this class. Again, so I was saying. Oh, yes, so I took it once like that. Okay, let's get to it. That's what next week you do sometimes. Oh, it's just online. Here, this is well, I mean, I found my company honestly in first. I didn't. You did two ways that I showed some big different stuff that study that was at the time for like 2 years or whatever. Yeah. So I've always stuff that anyways was yeah. So like I mean, as you know, it's yeah. Yeah, I mean, it's like I was like, I don't know, so it was like something that I put up. Not in like a I like it, but like in I was like, yeah, I love getting at least think it was on one there. And like it's just so lonely. It's so it's like that's like a found and when you press that or something. So, yeah. Well, I do.
Okay, good afternoon. We can go ahead and begin. It's going to be kind of a short lecture. Today that we have, we're going to wrap up chapter 7. I know a lot of you guys want to finish. Obviously, I have spring break next week, so that time and is for you. And we discussed there's nothing going to be assigned in that given period. Okay. So yeah, just make sure that you do your assignment 4 ahead, and we discussed assignment 4 last lecture, so you can go back to the recording, or if you have any questions, you can email me. And then for the demonstration, about the data breaches is very straightforward. I think, has anyone did it so far? The data breaches? Yeah, it's just a site that you go, and then you're just gonna do some filtering and then answer a question at the end, right? So obviously right now we're in week 9, and this is our week before spring break. So, and we are currently in chapter 7, denial of service. And we did some denial of service kind of attacks in the last lecture. And then we're going to continue today and just wrap up the chapter. So just a summary very quick before we dive into part 2, just to recap. Obviously, denial of service attack is it comes in multiple forms of different attacks that would fall under the main idea of denial of service, whether it's pinging, TCP flooding. We're going to cover some HTTP flooding today, to demonstration of a type of an attack. They would all do the same thing, and the intention is to kind of disrupt the given service or that given node so that it cannot respond to the intended users. Okay. It could be the idea of the goal is to kind of system resources, to disrupt those resources, to not make them available, application-based, or even the network bandwidth. And we discussed a little bit about the topology of the network that is being used. So this is the image that we talked about. This is a typical topology. We have switches, routers, and PCs, obviously nodes. We said anything could be nodes, and they need to communicate with each other. So that is an idea that to show you how denial of service is happening. So we covered last lecture classic denial of service, where we are pinging, and we're doing multiple pings, an increment of pings, to kind of, and we saw that the system CPU usage will spike up. So we did a regular ping last lecture, and we showcased the difference between a regular ping. Then we increased the attack in a little bit here. So what we did is that instead of maybe sending one packet, we would send 20 packets. Okay, so we used the -I flag, and that made kind of like the ICMP flood, because we know ping works with the protocol of ICMP. We talked about source address spoofing, and this is going to be important today as well because it's going to be used across the type of attacks, denial of service attacks, where obviously the attacker will change their IP address and they would attack the given system. Okay, so it makes it kind of stealthier of a denial of service attack because we really cannot know who is the given source. This is an example that we said if Bob and Alice are communicating, there could be the spoof attack that is being done where Trudy can impersonate Alice. We covered this SYN spoofing, and we talked about this is the initial handshake or the initial step in the given TCP handshake. And the type of attack that is happening here is that we don't do the final acknowledgement back to the given server or back to that given client in a way where we keep the handshake hanging, and that would take resources, and it would kind of do multiple computation, obviously for network usage, bandwidth, and that could kind of reduce and make the network more congested where it cannot respond to the actual users. So we also did the demonstration of that in class last lecture. So it's good to move on to what we have now. And basically, we're just going to continue. So let me present this. So we covered in the last lecture, or maybe just the last slide that I left from, we covered flooding attack, TCP, or you can say ICMP flood. Okay, so we did kind of flooding by doing ping, by using the ICMP protocol. Okay, and we know that ping is a network diagnostic tool that would kind of give us different statistics about what is being pinged, if the host is reachable or not, and if we obviously can connect. Obviously, there's time. There's about some packets that are sent. They're called probes, and we have time statistics for each packet being sent in that given, obviously, hop from that source to the destination. Okay, so we also have UDP flood. Okay, we would direct or kind of directly attack UDP packets. So the packets would change here to being a different transmission protocol that would be UDP. Okay, and we can also use the port numbers. And then we have TCP send flood, where we send targets to a system. Okay, and that raises up the volume of the given packets that we have demonstrated. So denial of service attacks, obviously we're going to cover some different attacks today, but it's using, there could be denial of service attacks that use multiple given systems to generate the attacks, okay? Maybe the attacker can use like a flaw, an issue kind of, or a vulnerability in the operating system or in the application and gain access to their program on it. That is the idea of the zombie. And then we have large collection of systems under the control of one attacker. These are the given bots that we have that are controlled by kind of the owner or the main attacker. And they created and they form botnets for us. So here's how this is get done, the architecture or the hierarchy of the denial of service attack from a top-down approach. We have the bot master, and this is going to be the attacker, obviously, right? He will control and initiate the given attack and kind of have all overall communication with all the other given nodes on the given architecture here. The handler and the commands servers that we're using, those are kind of intermediate systems, and there's specific servers names that can achieve this for us that would distribute these given commands or allows the attacker to kind of handle the zombies as kind of the agents. Okay, so the zombie agents or the agent bots, whatever you want to call it, these are kind of the compromised machines that carry out the attack. And then obviously we have a target, and this is going to be, it could be a server, could be a victim that's receiving a type of mass traffic. So far we covered ping, ICMP pinging. There could be UDP, and there could be with the given handshake, the SYN, TCP handshake. So we have SIP, and this is session initiation protocol. We're going to cover a couple of these session initiation because really the attack specifically happens here. So we're going to cover HTTP in a minute as well. And this given protocol is being used for voice over IP. So those are phones that would not work on traditional kind of landline. They would work on voice over given IP. Okay, and that given protocol will kind of be used to initiate and manage and terminate the given session for us, the communication session. Okay, so and also being used in video calls, maybe could be multimedia sessions and much more. Okay, so it would allow two given users to kind of reach an establishment of a session over IP networks. Okay, so what it handles setting up. So the initiation between the users. Here we have kind of two given calls, and here we have a server that is using this protocol call initiated. So that is kind of like a session setup before we get to the establishment phase here. And that would be kind of like, obviously, multiple steps are going back and forth. Okay. And the management is it modifies or maintain the sessions, and the use of that given feature is that, for example, if something to be wrong, maybe that session could be dropped or kind of closed, or they would obviously have different given features, or you could say time to live metrics that would handle the session. And the termination is obviously the end where the session is getting terminated. So some of the components that we have is the user agents. Those are obviously devices or applications that would send and receive the given calls. Could be kind of like the actual device or application, maybe like Skype, Teams, any of those applications that can send and receive calls. And then the proxy servers is what route using the SIP protocol between networks. And then obviously we have DNS servers, DNS resolver, and that can kind of help locate the correct destination server for us, because we send maybe based on domain, and then it can translate the domain for us based maybe on the IP or vice versa. Okay, so the SIP or that given protocol will control all the signaling process that is happening, establishes communication, and then maintains that session. Could be voice or video while that is being carried out. So here we have an example of that here. So we have, I'm not sure why this image got messed up, but we have user agent Alice here, right? And on LAN 1, and we have two different type of networks. We have a wireless networks on one side, the bottom right of the given image would be the bottom right. And here on the left, we have a LAN. So we kind of have two different, you can say, network types. The first step that would happen is Alice would send an invite, and that is the establishment, or we can say the first step of the session. Okay. And then that request is going to be sent to the local kind of proxy server that we do have here. And it's local proxy. It could be kind of a proxy server that is being used by the local given admins. They could have these given proxy servers. Okay. Step 2 is we would contact DNS server. So we would kind of query or perform a DNS query to return Bob's domain, and then that would return an IP address for us. Okay, so we send a query for this given domain, it returns an IP address. Okay, the invite is going to be sent. Obviously, that is sent through the internet, right? So that is forwarded across the internet and is directed to Bob proxy server. Then obviously the proxy server on the other hand that we have, and usually these proxy servers are installed at kind of like at the given host and destination. And they would receive the invite message, they would forward the message to Bob, and Bob would receive the request and they can accept or reject the call. So that is what's kind of happening, or kind of like the initiation of the given steps. So we move a little bit to HTTP, and obviously we know HTTP has we know have we have HTTP and we have HTTPS. For example, when we are in UCF, we're using HTTPS, and this website, for example, not secure. This is an HTTP website. Okay, so there's a difference between HTTP and HTTPS, as we know. One is not secure. Okay, there's no sort of session, or you can say a handshake that is happening on the back end. We know that HTTPS would use TLS. Instead, HTTP, there's no given session there. But basically, the idea or the core idea, the main objective of HTTP remains the same, right? Aside from the security aspect of the given protocols. And then obviously we have HTTP 1, 1.1, 1.2, and 3. Those are the advancements of HTTP that we do have. So usually the idea is it's kind of like a handshake that is happening. There's a session establishment. We are requesting given objects, and that is the HTTP request, and the response is going to be from that given application, or maybe the server that is hosting that given application. Okay, so the request could be anything here. Maybe when we download a file or we download an image, that is going to be our initial request. Okay, the server here on the other hand is going to obviously kind of reply, and there could be multiple users that are pinging that given server. Okay, it can respond to different kind of nodes that we have. So HTTP uses TCP as a data transmission protocol. So initiates a TCP connection, a three-way handshake connection on port 80. So we know that and we're going to demonstrate this here in a little bit, when we do hands-on and we want to work with HTTP, we would always use the given port 80. Okay, so the server would accept the TCP kind of connection from the client, and there's going to be HTTP messages that we covered in the last slide, the request and the reply that is happening. Then the session is going to be closed, so TCP would close it. We know that HTTP is also stateless. Okay, so it maintains no information about past client requests. So whenever you are using maybe HTTP site and you're requesting multiple objects from that given site, you are not those requests are not localized in a way, or they're not stored in a proxy server. Neither the given host can remember them. So every request is a new initiation, or you can say a request. Okay. Protocols that maintain state are complex, and so past history state must be maintained. And if that server or the client crashes, the state may be inconsistent. Okay. Does anyone have an idea of how HTTPS now, or current browsing, is maintaining that, or kind of shifting from that stateless to be a state kind of where the information is being kept? Yeah.
Yeah, so with HTTP3, you use what actually uses the kind of application you're trying to serve. You use WebSockets that to deliver content and signals, like a signal packets that you send over. So instead of having you have this reliability form that opens a lot more out, a lot of applications as well.
That's correct. So that's but how does the information get maintained? It gets stored in a way. For example,
you either have your local storage that gets saved within the browser, and the server that needs to get sent back server side. You have again using that signal packet that you're using with HTTP3.
Yes.
And that data gets sent back to the server.
Yeah, that's correct. So two things that you mentioned. The first thing, a little bit kind of not relative, but it's obviously modern today that we're using the QUIC protocol that combines multiple protocols under one. And the other thing is that, as mentioned, local proxies servers can be used to maintain the requests that do happen. Instead of initializing a new ping request or an object request from that given domain, those are going to be stored. Another way the information is maintained is through cookies, right? So cookies will maintain the information for you such that when you come back, the local proxy server has maintained sessions. Those sessions will store those cookies for you such that when you maybe log into Amazon and you add maybe some given item, could be a blender, anything, you go back to Amazon, it would be kind of in your given cart. Or maybe a download session that is, once you go back to it, it kind of resumes or maintains its given session. Okay, so let's get to the attacks. There's two types of attacks that would fall under the HTTP protocol for denial of service attacks. Okay, so the first one that we have is this given attack, slow LURS, and we are sending HTTP requests that initially would never complete, kind of similar to TCP handshake. Okay, and we are trying to maintain or keep the sessions or the connections open for the web server. Okay, so attackers would slow and partially send these given requests. The server will keep the connection open, waiting for completion, and there's many connections that are happening, and it would exhaust the server that we do have. So this is a normal HTTP connection that we do have, just a request and a reply. What we do here with the denial of service attack is we send requests and those are not going to be closed, right? We maintain the session. So, and obviously those would cause incomplete HTTP requests after a certain time. But the idea is that with deploying these sessions or these requests on kind of like similar how we did kind of with ping, we flood with multiple given requests at a certain time. Okay, so we need to switch to a little bit to Kali now. So I'm going to launch my virtual machine. So I think I mentioned in the previous classes, you're gonna need to install Metaexploitable 3 for one of your assignments. So make sure you do install that. And on the assignment itself, once it gets released, there is information there. But if you want to take the initiative and install it quicker than that, then you are free to do so. Okay, so the first thing that we're going to do is obviously we're attacking a target, and the target is going to be Metaexploitable 2. The first thing that we're going to do is we're going to check if the server is up. The HTTP server on Metaexploitable is up, and that is the port 80 server that we have. Okay. Okay, so let's go back to the slides. So to confirm the target is up, we will do curl. This is a command, and we're using minus kind of I here for checking the HTTP for this given kind of IP address. Okay, so obviously we will receive some statistics from the request, kind of similar to ping. And what we're looking for is we're looking for the status code of 200. Okay, so there's multiple status codes. Can anyone name a few that you do know off your head? Yeah, 304, 404. We have 304 as well. There's a couple of other ones. So HTTP status Close. There's a lot of them now. There's one that is for not found 302, for 6 not acceptable. That gateway forbidden has been moved. So when a website has been moved to another domain, it would kind of give you that given reply. Okay, so the 200 is the one that kind of lets us know that the server is up and our request is successful in a way. Okay, so let's do that. We will go to Kali here and we will do curl and minus I and HTTP, and then we type in our 2 / then our IP address for MetaXplorer 202. Oh, it's .3, not .5. So yeah, we can see that the date, it's using HTTP 1.1, and there is HTTP versions 1.1. There's images, that would be good. Well, this is good. Yeah, this one supports caches. So HTTP 1.1 doesn't support the caches and has persistent connection, meaning that when we're using HTTP 1.1 and we are requesting multiple objects from the website, the session is going to be remain established in a way that we can request multiple objects. It could be 20 objects, 15, multiple images, and the connection would remain open. But with HTTP 1.0, we would have a connection or kind of an initialization of a session per given request. Okay. And obviously that would cause a lot of time consumption that we have. And this slide does not cover the 1.2 and the 1.3 that we have. This is really good. So we have HTTP 1.0, 1.1, and then we have 2, and then we have 3. Okay, and that is the one that we're kind of modernly being using now. That is based on Google Quick, that uses UDP instead of TCP. Okay, so when you're doing kind of Wireshark and capturing, you might notice that you have this given protocol, which is called Quick. Okay, this one allows multiplexing, and do we know what multiplexing is? It's a kind of a fundamental networking concept that we just should be discussed at least, is that when we multiplex, we take multiple requests from given users, and this will be demultiplexed at the given server. Okay, so where we can combine multiple given requests. Okay, so we know that there's an Apache server that is being used here and some kind of given content. So the next thing that we want to do is we're going to kind of check if that service or kind of that given port is open. So we always do Nmap, but here we're not doing a typical Nmap. We're specifying port 80 for HTTP to identify the given web server. So we're going to do Nmap with a service detection using port 80 here. So that is going to be Nmap and then SV and port 80 and then our IP address. So there's one host. I'm not sure why it did. Should have not did the other ones. Should just check for. Oh, I think we missed. Yeah, the -P to check for port 80. So that's gonna be is -P. So it should be relatively very quick scan or just check that we do have, and it should show us the port number, and it should show us that it's open alongside with maybe the MAC address. Oh, that is weird. I think it's a lowercase p, right? Yeah, it's lowercase. Sorry about that. Let's go back here. Yeah, this is good. This is what we're looking for. So we have port 80, it's the state of it is open, and then we have the MAC address is being used. So the host is up, and then there's one address that is up. So the next thing that we want to do is we want to open a terminal on an exploitable side to kind of capture or to see the connections, the HTTP connections as they appear, as we make the request from the attacker side. Okay, so you can use either of these, netstat, we're both, you can use netstat or TCP dump that we used for the last lecture with ping. Here we also are specifying port 80. So we want to have this kind of open to kind of capture any given requests. So we will go back to on this side, the vulnerable machine, and then we will do sudo and then TCP dump, and that is going to be for any TCP port that is using port 80. Else? Yeah. Okay, that should do it. Okay, so we're listening for any kind of, we're in a listening mode. So what we do now is we initiate these requests. So what we'll do is, and this is kind of the slowest style demo that we do have here. So we will do NC and then obviously use the NCAT, netcat here with given port 80. And then once we reach an establishment of the session, we can request maybe certain things like get HTTP 1.1. We want to get that and get is a command and being used in HTTP to get a specific object that we do have. We type in the host, but we don't close the connection in a way. We leave it open. Okay, so kind of this is the tactic that is being used here. Obviously, we're doing it on a scalar mode, a small scale mode here. But obviously, imagine if it's being botted here. We have multiple bots that are being used to kind of demonstrate or kind of redo the idea that we have. So what we'll do is we'll go back to Kali, and we will do NC, and then we provide the IP address to the 3, and then we do port 80. Okay, that should be working fine. If we receive maybe something that is like no route to host or some sort of error, that means it's that would be an issue. So now we have kind of a session that is kind of starting, and I think if we go to on the Kali side, you can see a little bit of stuff that we do have here. So from this IP address, we're getting kind of requests with different socket numbers that we have here. And there's an acknowledgement one that is being made from obviously, and that is the first kind of interception from the other machine that we do have, is to acknowledge the request or to kind of give an okay. Obviously, if I would leave this would time out by itself. Okay, so there's also a time kind of limitation, or you can say similar to time to live with networking is also included with HTTP requests. Because imagine if you have a persistent HTTP connection and it's going to be remaining open until you close it. Sometime you are going to leave it open, so it would close on its own. But if we do here, maybe get and then HTTP 1.1, and then maybe host. We want to type in the host, that is our host, 2.3. And maybe we type in the user agent. and this could be demo. Okay, but we don't kind of finish the request here. So really this is the idea that is happening here. The session is remaining to be open. We have to, in order for us to kind of close it, it's still, this is in open listening mode, but the session kind of will be closed here. Okay, with a given timestamp. So we observed the connections. We did see the HTTP connections on port 80 coming in from the attacker side, and the server received a request start. Okay, the headers are kind of incomplete because the connection will stay open till we make any kind of connections being made. So the connection will stay open, and the server will kind of wait. Okay, so if we do this on if we open kind of multiple terminals here and we would do the same thing, you could see how that could kind of flood the server side of the attacker. So we move to HTTP flood. So this is kind of HTTP flood using this kind of demo where we are launching multiple kind of terminals, emulations, and we are launching kind of an HTTP given session and we're maintaining it to be open. HTTP flood is would attack or you can say bombard the HTTP server with web requests. Okay, so obviously that would consume considerable resources, and the bots would start from a specific page and they automatically would follow a link from the site. So it's a recursive kind of type of attack that we have here. From one specific page, it would follow links across the site. Okay, so this could on a given object here, maybe if we go to this one here, this kind of website, everything is considered an object on the website here. When we click blog, SSL tools, and this would kind of redirect. This is to be used a persistent type of attack where it would kind of, the session would be remaining open. It would kind of request multiple things from one given kind of domain. Okay, so this obviously will generate very many legitimate looking requests to serve. So what we'll do on here is we'll change it a little bit, and we want to kind of monitor Metasploitable and kind of the logs of it, like what is happening, time, CPU, memory, and stuff like that. So in order to do that, we will use top here. So or you can do this one here. So I will just use top. So I will go here, end it, and clear, and I will do top. Okay, so really nothing is happening right now. There's no requests, there's no initiations, and everything is kind of working fine. Oh, we have this one from the Tomcat server from, yeah, so it's kind of a demo for another class, but yeah. This is a vulnerable, obviously, this is a vulnerable kind of a Java web browser. So what we do is we go back here, and this would obviously allow to see kind of connections or CPU usage. What we do on this side is we kind of use Apache Bench, and this is kind of what's recommended for the demo here. And what we're doing is we're sending about 5,000 requests and 100 concurrent connections. Okay, that is the -C and the -N that we do have here. Okay, so this will obviously first it will simulate multiple requests at the page at once, and we have 100 of concurrent connections. Okay, so let us kind of demonstrate this really quick. I want to have it side to side if I can. And then, so you can see this here. This is good. Okay, so to use the Apache Bench, we will do AB here to use that. And then we are going to send the total number of connections. We can do 5,000 for that. And then -C for concurrent connections. And we can do 100. Then we also need to specify the IP address. So it's going to be HTTP / the IP address. Okay, and then ending here. Okay, so you can see how there's a lot of requests that are coming on, obviously, Metaexploitable side from the Apache server. And then Kali is going to report to you how many requests were completed. So we have completed 500 requests, and there is still requests to be made. And you can see how the CPU or the memory is kind of spiking here, obviously, with this kind of metrics that we use for the attack. Let it run here for a little bit. It's going to take some time to kind of finish. But this obviously is the other HTTP attack that we do have, is to do an HTTP flood with multiple given requests. So we have kind of flooding, ping flooding, and HTTP flooding, and we have kind of the handshake. We initialize the handshake as well, whether we're doing the SYN of the part of the TCP handshake or part of the HTTP handshake is to keep it open as well. Does anyone have any questions? Okay, that's good. So obviously what is happening is that one normal traffic is obviously one user, one request, where we're flooding like maybe 100 bots. There's 1,000 of requests that are sending at the same given time. If we're using 100 bots per given maybe 5K connections or 5K kind of requests, even though the requests are kind of legitimate, the server will not be able to kind of handle them. Okay, so the key idea is that behind the stack is that we would use legitimate requests instead of malformed packets. Okay, they make them harder to detect, harder kind of to block, and that's very effective against web servers that we do have. That's why we're using kind of HTTP here. I think this will finish. Okay, so this kind of gives us a lot of things here, some stats. So the server host name, Apache, the host name of the IP address, port, document length, the concurrency level that we set, which is 100 here, total transferred in bytes, HTML transferred, requests per second, 57 requests per second, and the time per second that we do have here, and the transfer rate. Also with some kind of like median, an average and max. Okay. So a total of requests were sent about 4K there. So there are some that were not kind of happening here. Yeah, 4,869 requests that we have here. This is for obviously the other attack is that you would repeat with few terminals, open 2 to 5, and you would do the same thing. And you would kind of, what this happening is opens many connections, partial headers, and the connections remain alive. We never are completing the requests. We move to reflection attacks, is that where the attacker would kind of send requests to a legitimate service using spoofed source IP address. Okay, the same idea is happening here. The server would process them and they would not know, and obviously send the request or the response to the victim. And how it works is that the attacker would obviously spoof their given IP address, and the systems will send responses to the target. And obviously, this causes a very large amount of traffic to be sent to the victim. Okay, so that is kind of often kind of a large scale of denial of service attack that we do have here. We generate enough reflected kind of traffic to overwhelm the victim network or system. So we're kind of doing the opposite here, affect the victim, not the given server. So here's an example on how it's done. We have a normal user, and obviously the first step that we're making here in this given figure is that we're contacting the DNS server. And we have our, you can say our IP address here, which is wx.y.z. That is the to address of the DNS server, and then our from address. And these are kind of port numbers that we do have here. So 1792. And then that is a normal kind of behavior that we do have here. The request will be replied back. What is being done here is that the attacker from this given address would kind of contact the same DNS server. Okay. But their original IP address is this, a.b.c.d. So they would contact with a spoofed IP address that we have, the j.k.l.m. That would be sent obviously to here, and it would kind of be sent to the victim instead. Okay, so because that IP address is a victim IP address, and that would kind of be in a loop if we do kind of multiple given requests, and that is the DNS reflection, impersonation, or forging of IP address that we do have. Amplified kind of attack, amplification attack that we do have here is that they would increase the volume of the given traffic to that is sent to a victim. So we attackers would send small requests using that obviously a spoof victim IP address. And how it works, as we kind of demonstrated, the request will be sent to public servers, and the servers send much larger responses to that given victim. Okay, the small attack will kind of generate massive traffic towards the given target that we do have. Okay, so we have an attacker that has zombies, they're forged IP addresses, and we're sending multiple requests. So to increase the rate of the attack is obviously given or kind of a mechanism that the attacker kind of controls. So let's come a little bit to defenses of denial of service attack, and we have different stages. You can say for the given attack, we have before, during and after, and kind of a recovery. Okay, so you can say 4 lines of defense. So the attack really cannot be prevented entirely, that we do have, but we might have obviously high traffic volumes. They could be legitimate, and activity maybe there's coming from a popular site, or something else. So the attack prevention and before attack that we have is the first type of way we can try to reduce is before the attack to happen. And we're going to cover these stages in detail. And then we have attack detection and filtering. Maybe we can use some IDSs here, intrusion detection systems, or you can say devices, or that given mechanism. Attack source, traceback, and identification, we would try to kind of debrief or debug kind of and find the given kind of source. And attack reaction is after kind of the attack, what is being done. And that's usually the incident response plan that would kind of cover all of that. So to prevent, obviously, the denial of service attack is that we filter packets with source IP addresses. Okay, so we apply filtering as close as possible, and we could have kind of a firewall that would kind of filter for HTTP or kind of like, yeah, for HTTP requests based on the source IP, and to kind of reduce these kind of spoofed IPs or kind of block them. Okay, we can use filters to verify the packet, follow a valid return path. So that is kind of like should occur before traffic leaves kind of the system or the ISP, kind of to see the path of that given request that we do have. We have connection handling protection that uses kind of the TCP send cookies to validate the requests in a way. And that kind of helps validate if the requests are legitimate or not. So that helps prevention of the exhaustion of the server connection table, right? Because the idea is that those connections, as they append more and they increase, they would kind of not allow the server to reply. Okay. Resource management is we remove the connections that when the table becomes full. So obviously that buffer in that given table for the server is to drop, and we are doing good with that by using the time constraint, obviously with each request. So was it on the next Kali, I think here that we have, right? I want to see something. When we did the NC, so if we go back and we can have it running in the background. We do the NC here, and I want to show you that timeout that would happen. So we can leave that. But obviously we'd kind of get some stats where the connection kind of ends on its own. So the idea is that we are preventing and trying to kind of stop spoofed addresses and protecting the server connections as they kind of increase. To prevent them is we block network abuse, so we block IP address broadcasts, disable those services that can be used for amplification. Okay. We monitor the traffic as well, so we block suspicious traffic patterns that would come, restrict some risky service combinations if they are there. We can use CAPTCHA, right? And we are using that now, where you have to kind of distinguish where actually there's bots or humans making those requests. And then infrastructure protection is we use kind of mirrored or replicated servers to improve availability during those attacks. Okay, so we combine some techniques, whether we block IP addresses, use firewalls, and many things to kind of have a resilient kind of system that would be very robust against these denial of service attacks. And then obviously responding, and this is kind of like post incident or post attack, is to there were going to be details, obviously, for the insiders maybe, and for the organizations to follow on how to contact technical personal ISPs, how to kind of impose traffic filtering upstream, details on how to respond to the attack. Okay. So anti-spoofing that we have, or direct broadcast, maybe rate limiters that we can limit, should have been implemented. Okay, but ideally the network itself should have IDSs to detect and notify if there's any abnormal traffic patterns or kind of requests that are happening. And one way to do that we kind of cover is firewalls, and we know that firewalls are kind of to be used as kind of a middle box in the given network, and they would separate the internal LAN, or you can say the internal traffic from the external traffic, right? From the good guys maybe to the bad guys, okay? And we can modify those by access control list or multiple kind of rules that the firewall would tend to follow. Intrusion detection systems would not block, they would only detect. They operate on the TCP/IP headers only, and those TCP connections like we have with HTTP. And they would look at the packet content, check there's characteristics in the given packet header against the database for known viruses or attack given string, similar to vulnerability kind of detection. Okay, like maybe we have Nessus or OpenVAST, the same idea would get done here. Okay, so we would check multiple packets for maybe port scanning, network scanning, denial of service attack as well. And here's the intrusion detection systems. We have our internal network. We still have a firewall to separate between the internal and the internet. And we have the DMZ zone here where we have multiple of our servers, proxy servers, load balancer servers, and we would have these ID sensors kind of everywhere here. Okay, these are going to web monitor the given network, or you can say the requests for us. So to respond to denial of service attacks, we identify the type of attack that is there. We capture, analyze the packets, design how to kind of a detailed kind of a plan on how to block traffic and the traffic maybe flow or stream, identify the correct systems and applications, okay, and then or the bugs, if there's any, trace the ISP or packet flow back to the source. It may be difficult and time consuming, but we can kind of do that. If planning legal actions, we can kind of contact or get in touch with the given ISPs that we have to find the original source. We can have an implement a plan. So maybe some plan as a backup plan to switch to alternative backup servers to keep the availability, obviously, of our services running under the CIA tried, and then commission new servers at a new site with a new address. Okay, and then update the incident response plan as we go or as attacks come, such that it can be kind of recent or up to given date for future given handling. So that is chapter 7, and obviously it's about denial of service. We talked about how the nature of the given attack. We covered the types of attacks. We covered the classic source address spoofing, SYN spoofing. We talked about the type of floodings, ICMP, UDP, 2CP, HTTP as well. Some defenses against denial of service that we talked about, kind of to filter traffic as well, block certain IPs, use firewalls and IDSs, responding to denial of service attacks as well, how to respond to it. And we can have application-based attacks, which is the SIP flood for voice over IP and HTTP-based attacks. Okay, so there's reflectors and amplifier attacks that would kind of mass generate kind of the given request, and that is to be attacking the given kind of client, whether it's reflection, amplification, or DNS amplification attacks that can be done. Okay, so that is a summary, or you can say kind of a conclusion of chapter 7. We will take attendance, and then you guys will be good to go. One thing to note, I'm going through the submissions of assignments, is that when you submit your assignments, you would want to provide screenshots and provide captions under the screenshots, right? So you provide what you are kind of demonstrating in that given step. To provide just screenshots, and it makes it very hard. Obviously, you're going to get points deducted, but it would make it very hard for us to follow these given steps, right? So you would want captions and write some description, and vice versa. So you cannot just type some things without obviously the snapshots. Okay, so let's take attendance. So if you're on Zoom, if you don't have any questions, you're good to go. I wish everyone have a good spring break.